very long session. I will try to finish it fast. So regression analysis, most of the times you will be confused or you will be afraid of this term regression analysis. So regression is the most interesting point in the statistics if you understand that. There are two types of regression equations, linear and logistic. When the outcome is continuous, we have a linear regression. When the outcome is categorical, binary, logistic regressions. Here we will discuss about the simple linear regression. Simple predictor is average speed of vehicles in a day. I am the traffic inspector of National Highway. I am measuring the average speed of vehicles in a day and number of accidents on that day. I am observing these two parameters over 50 days. And I ask two questions. Is there an association between this average speed and number of accidents? Second question, can we predict the number of accidents in a day for a given speed? So if I know the average speed is say for number of accidents on that day. The first question is answered by correlation and the second question is answered by the regression equation. And similarly, I have another study. Say as Karthikeyan sir said, I am measuring placental thickness in ultrasound for the pregnant mother. Again, I ask two questions. Is there an association between ultrasound measured placental thickness and the gestational age? And second question is, can I predict the gestational age based on the placental thickness measure? Coming to the correlation and the correlation to apply the scatter plot. Say placental thickness on this axis and the gestational age on the y-axis. And we are going to get a picture like this, any one of these 5 pictures also increases. So there is a positive correlation. Here there is a positive correlation but it is weak. And here it is no correlation. If you get a scatter plot like this, that means placental thickness has no correlation with the gestational age and there is no meaning in measuring the placental thickness. And if you take this, say like a number of holidays in a school and pass percentage, marks of the students. So if the holidays increases, the marks will decrease. So there is a negative correlation. Coming to the equation, you are going to predict something. Say like number of accidents on a day based on the speed or the gestational age based on the placental thickness. After you obtain the scatter plot, you try to draw a line. It's a line of best fit. So like in continuous data, you had a mean where half of the values will be on this side and half of the values on that side. And similarly, we try to create a line of best fit where the values will be equally distributed on the either side of this slope line. This line has two components. The intercept, that is when the value is 0, when the x is 0, what will be the y? And this is the multiplication factor beta 1. That is called slope of the line, regression line. You have to multiply the placental thickness by beta 1 and then add this intercept. You get the predicted value. So this is the gestational age for this placental thickness. It is obtained by the least square method. This is similar to the mean and normal distribution. Data are on either side of the regression line. So I have told you this is intercept, this is slope, and this is the measured placental thickness. So this is the study as Karthikeyan sir suggested and presented. We have a beta, this is the beta or the slope and this is the intercept. We can calculate for first trimester, second trimester and third trimester and you can combine all the values and you can calculate for the whole antenatal period as a whole. So we need to calculate these 4 things and understand these 4 things. The beta, that is beta naught is the intercept, beta 1 is the slope, R is the correlation coefficient and R square is called coefficient of determination. What this signify? And beta naught is the intercept. I told you beta naught is the value of y when x is 0. How many of you agree with this? See, 0 means placental thickness is 0. How can a 0 placental thickness can have a gestational age? So it's only arbitrary value. This intercept is an arbitrary value. It doesn't have a real value. The meaning is it is within this limit of measurement. So there cannot be a gestational age of 4 when the placental thickness is 0. And similarly, you can extend this type of regression equation to the categorical data. It is not only the continuous data like placental thickness. You may extend this to male and female, heights of male and female, group A, group B. So, and more than 2 groups, say A, B, C, class sections A, B, C, and you are going to measure the marks of the 25 students in each section, you can get a regression equation. This is the logistic regression. Very simple. When the outcome is binary, say yes or no, alive or dead, or pass or fail, we are going to get the logistic regression. Simple. Only difference is in the left side. Otherwise, the equations look similar. Intercept plus slope, intercept plus the individual group slopes for the individual groups. Only thing is it is expressed in log and odds. You get the value, you have to take anti-log, then only you will get the odds. So you will be getting standard error in logarithmic scale. You have to get the standard error confidence limits in the logarithmic scale and then convert it into anti-log normal scales. So here we take binary categorical data, that is height of male and female. It will be expressed like this. Intercept plus slope, where x1 is 0 for females and x1 is 1 equal to 1 for males. So female is the reference point, the slope. X1 is 0. So they will form the reference group and you will get the value for males if you apply the slope calculation. So look at here, this is the formula, regression equation, y is equal to 150 plus 10 into x1. For females, see x1 is 0, so you get just 150. They intercept, they behave as the reference group. For males, 150 into slope into 1, so they get 160. So very simple. So regression is not a big thing to understand. But somebody may have male as reference group and female as next group. Here you will get like this. Here 160 minus 10. So the male will have 160 and the female will have 150. And again the value will be expressed with 95% confidence interval. Here we have three groups. Say birth weight of children in Delhi, Mumbai and Chennai. How the regression equation is going to be. See beta 1 intercept, beta 1 into x1, beta 2 into x2. So we have 3 groups and the beta naught is their reference group, Delhi, where x1 will be 0, x2 will be 0. For Mumbai, beta 1, x1 will be 1 for Mumbai, x2 will be 1 for Chennai. So if you want, you apply the values and you can get for Delhi, for Mumbai and Chennai. So from the simple regression equation, you have to apply the values 1 or 0 and get the birth weight of that city. And you will get standard error for each value, Mumbai, Delhi, Chennai. So coming to this part, understanding the regression analysis, what exactly it does. So we have two continuous variables, say placental thickness and gestational age. Both are continuous. So each will have their own mean. X will have a mean, Y will have a mean, and X will have a variance, and Y will have a variance. You will have a standard deviation for one value, standard deviation for another value. Usually we do like this. What else we are going to do? This is known as the covariance. Covariance means it is the measure of joint variability of X and Y. If placental thickness increases, gestational age increases. But how far they jointly vary with one another. So if the speed of the vehicle increases, number of accidents also increases. But how far they jointly vary, that is the measure we are going to see here. Covariance. See, this is the value we are interested. So we are going to calculate how far it is from Y mean and how far it is from X mean. So calculate the difference, X minus X bar, Y minus Y bar, multiply them. It is called cross product. Cross product of differences. How far they vary from their own mean. You get the cross products for each value. Then take a mean. That is called covariance. So what information this covariance is going to give? The problem with the covariance is, if I apply placental thickness millimeter, it will have a different graph. If I give centimeter, it will give a different graph. So it varies by the scale, and it can take any value from minus infinity to infinity. If there is no totally relation between these two variables, the covariance may be 0. Because it is not scaled, we are not able to get a good description. Somebody may say covariance is 100 based on millimeter. Somebody will say it is 1.2 based on centimeter. So it doesn't carry any meaning. So what we should do? We should scale down the covariance based on some factors. So if you scale down with reference to X, various X, or you can scale down with the combined variance of X and Y. So if this is the covariance and this is the combined variance of X and Y. If you scale down the covariance by this, you get the correlation coefficient. The advantage is, it will not vary outside this range, -1, 0 to +1. While covariance varies from minus infinity to plus infinity, it doesn't convey any meaning to us. But here see, -1, 0, 1. 0 means no correlation. -1 means there is a very strong correlation, negative correlation, like what I told. If the holidays of school increases, student mark decreases. +1 is the positive correlation, and closer to 1 is the stronger correlation. When the vehicle speed is more, then number of accidents is also going to be more. And if you scale down the covariance with only X variance, you get the regression slope. That is the beta 1. This is the measurement of association. This says whether there is the strength of association, and this quantifies the association. So this is how we arrive the line of best fit. So we have calculated the slope. So we have calculated the slope. Based on the slope, there is a formula for calculating the intercept. So we have intercept is arrived, slope is arrived, so our equation has been derived. So what is the difference between covariance and correlation? Correlation is nothing but scaled covariance. This assesses the joint variability, while correlation assesses the strength of the association. It is minus infinity to infinity, this is minus 1 to 1. So you can compare across domains. If you see placental thickness, the same value you can describe. For vehicle speed and accidents, you can describe from minus 1 to 1. So you can compare across the domains. So it is affected by scale and it is not affected by scale. Coming to R square. So we have the line of best fit, and I take this value, and how far it is from its y mean. And this is the point where the predicted y lies. Am I right? So the line predicts the y value for this x value. So this is the predicted value, and it is far away from the mean. So there are two positions. This point, so this green line, this deviation is explained by the regression equation. So regression equation explains this, allows this deviation, but this red is beyond the equation, regression equation. So this is not explained by the regression equation. So this error is called explainable by the regression, and this error is random error, which is not explained by the regression equation. Now we square them, sum of them, and take a mean. The squares, if you add, it will be coming to the sum of squares total. So what is coefficient of determination? So sum of squares total, out of which sum of squares regression, that is the regression line, the difference expressed or explained by the regression line, you are going to square it, and you are going to take a proportion. So for example, r square 0.64. What does it mean? That means 64% of the deviation is explained by the regression line. So regression line explains for the 64%. 36% is the random error. If the r square is very low, that means regression line is not able to explain the deviation, and all of the remaining percentage is error. So 36% is unexplained random error. And incidentally, correlation coefficient is square root of r square. If you calculate one value, you can derive the other value. So we have seen all the four parameters: slope, intercept, r and r square. Say look at this study. They have given slope, intercept, r square, and look at the r square is 0.53. So this is r. If you square it, you get r square. So these four values will be given in the regression equation. Don't be afraid. These are all the simple measures to follow the regression equation. So look at this. R is 0.87, 0.557, 0.67, 0.727. So it is almost closer to 1. That means there is very strong correlation. There is very strong association between the placental thickness and the gestational age. So we can comfortably predict gestational age based on the placental thickness. So this r square, what does it mean? Only 53% of the deviation is explained by the regression equation. Look at here, r square is 0.44. Only 44% is explained by the regression equation. So coming to confounders and effect modifiers, this will take only 6 or 7 slides. I will try to run through it. So regression is very effective in finding out confounders and effect modifiers. You will be fond of regression after this session. Though you will be afraid now, but later in your life you will be very much have a liking towards regression equation. You will be very much interested. Now what is a compounding effect or compounder? There is an independent variable and there is another independent variable which may act as a effect. So coffee drinking and myocardial infarction. So I say that coffee drinking increases the myocardial infarction. So there is a third variable, smoking, which can increase the coffee drinking. So whenever they smoke, they will like to have a coffee. So it increases, it affects the relation between independent these cause and effect. So it increases the coffee, as well as smoking can also cause myocardial infarction. So it affects both the exposure as well as the disease. Another example is classroom marks. So there is section A, there is section B, and we are going to analyze the marks. Here the confounder is gender. The class A may have 80 girls and only 20 boys. Class B may have 25 girls and predominantly boys. And as usual, girls may study well and boys will roam around. So what do you get? Class A performing well. So here gender is the compounding factor. It unnecessarily gives credit to the class A. So there is a spurious association and there is a suppression of the information, or it can be an enhancement. See, actually these 80 girls may be performing low, but just because the numbers are high, it gives a better result. So we want to rule out the effect of gender. And sometimes change of direction. See here, overall this section may be performing poor because girls have been in more number. Class A is getting credit and it has been given prize. And coming to another example, weight and mid-arm circumference in a village. We are going to weigh the weight of the child and look at the mid-arm circumference. Both are continuous variables, and you are going to get a relation. Say when the child is obese or have more weight, the mid-arm circumference is going to be high. But there is another compounding factor, that is age. When the compound factor is a continuous data like age, it is called covariate. So it may affect the weight as well as the mid-arm circumference. So here also, see here, city A, you are taking 100, 80 young persons and 20 old. In city B, 25 young and 75 old. City A, because the young persons are more, mid-arm circumference may be more. So you will wrongly conclude that city A is nutritionally well balanced and all of them are very happy. But actually it may be wrong. Then coming to effect modifier or the interaction. This is also a third variable. How it is different from confounder? The effect modifier, here is an example how to identify the confounding and effect modifier. Here the example given is classroom marks, 80 girls, 20 boys, 25 girls and 75 boys. The regression equation is 0 for class A and 1 for class B. So gender is the compounding factor. It can affect the marks. So we have to bring the next component, the x2, beta 2 into x2, second slope and a second, where x2, 0 for boys and 1 for girls. So we can go into through aspects. One, gender adjusted value. This will be done in software. If you give the command, it will do gender adjusted. That means the gender adjusted value for the comparison minus 10. That means gender has an impact. Gender is a compounding factor. If there is no much of variation in the intercept and slope, then gender has no compounding effect. What else we can do? Stratified analysis. You take class girls, then class A, class B, or you can take boys and then class A, class B. Stratified analysis. So you do class A, class B analysis in each gender, boys and girls. Look at here, it is 78 here and it is 57. That means gender is a compounding factor. If the stratification doesn't have a dissimilar results, then gender has no effect. So this is the flow chart. To summarize, this is the regression equation you got for the two predictors and the marks. First question you ask whether adjusted values are similar or not. If the adjusted values are not similar, then you go for interaction. Report stratum specific odds ratios. So if the adjusted values are similar, say like 68 and 72, you can say that there is no big effect on the confounders. Next thing, whether you want to give a crude effect is equal to adjusted effect. If it is not there, there is a confounding. If it is yes, there is no confounding, no interaction, you can just like that report. This is a final slide, I think. We will complete it. So look at this class B girls, where x1 is 0 for class A and 1 for class B. This is the equation. 0 for boys and 1 for girls. This is the interaction term. So you have deducted the interaction. The beta 2 is an interaction factor. So you need a correction for that. So you have to add the correction. And this is how you calculate this. I will not go into that. So you will have 4 combinations. Applying all these, you will get a value for each. Say class B girls, class B boys, class A girls, class A boys, you will get 4 values from one regression equation. So your regression equation is this one, and you can get values from this equation for all the values. So in all these situations, there is 0. This value becomes 0. Interaction term is 0. Either because of this or because of this, all these 3 values are linked. Only interaction term is here. That is, girls have an interaction effect over the classroom in marks, assessing the marks. This one is, you have found the confounder. Here is the continuous data. It is called, when the confounding factor is continuous data, you call it as covariate. Then what you should do, you have to calculate the adjusted value. See, here it is 70. If you have arrived at the adjusted value, there is a difference. So it could be a interacting factor, that is the effect modifier. The hours of study is an effect modifier. So what you do, you have to assess the linearity of the effect of hours of study, whether it is linearly affecting or not. So you have to divide into 4 groups. calculate the slopes for all the groups. See 5, 7, 9. There is an increasing order, and the difference is uniform. It's a linear. So you accept the linearity of the covariate, and then only you can go for the adjusted value and find the difference. So to summarize, regression is the most effective form of statistics. I am re-emphasizing that. You may be afraid of regression equation now, but later in your part of life, regression equation is the most interesting part in statistics. So correlation coefficient assesses the strength of association between two variables, like that is predictor and outcome. For example, average vehicle speed and the number of accidents. Regression equation predicts the outcome based on some equation. For this average speed, I will have this many number of accidents. Regression is also used for categorical predictors, as I have explained. More than one predictor, it goes for multiple regression. Confounding an interaction, they have adjusted values before getting reported. For binary outcomes, we need logistic regression. In logistic regression, the equation will be in logarithmic form. You have to calculate the value and convert it with the anti-logarithmic scale. You will get the real value. I think all of you will be crying like this after listening to this lecture. Thank you very much.